Okay, so today we're going to just talk really quickly about clustering. Um, Clustering is something that is useful for different reasons. One, grouping your data, obviously. It could also be a very powerful EDA tool to just like learn about your data and like just the distribution of it. So yeah, I think something that's hard about clusters is not always so straightforward, especially deciding the number of clusters. I think that's like one of the first blockers that people face. Yes, we talked about the metrics like the elbow curve, the silhouette score, but it's not always so obvious. You don't always get like a nice elbow curve. Sometimes you end up with like a line that almost looks like a slope. And then with the silhouette scores, it's kind of like a relative score anyways. And so it's not always apparent the number of clusters. The thing with clusters is, and it's always helpful to remember, is clusters are grouping your data based on the numbers that you're feeding into the clustering model. So it's doing this purely based off of math, where the data points are in space. And so it's not taking any meaning into context, especially so when you have like a lot of dummy variables. Just to let y'all know that this model exists, if you do have like mostly dummy variables, a model that runs a little bit faster for clustering, if you're looking at doing something like k-means, there's another one called k-modes that was brought to my attention recently. It works the same way, but apparently just works better with very categorical data. I don't think the results will differ very much, but I think it runs a little more efficiently. So just so you all know, there's k-modes clustering. So when you're trying to decide between clusters, I think there are several scenarios. So one, maybe like you have a whole range of clusters that are giving you okay values. I think what is most important here is to really think about your context. If your like elbow score is saying that like, okay, 3 to 7 clusters all are pretty good. Like every time you have like a significant improvement in your score. If 3 to 7 clusters is good, what do you think makes sense in your context? If you want to take your data and identify them by their groups, how many groups make sense? So the example I always give is like, I don't know why it's a sports example, but like basketball players. I only recently figured out that only 5 people play on a basketball team at a time. But a student was working on a project like clustering basketball players in their different positions and was like, okay, my model is telling me 3 clusters works or 7 clusters works. I'm like, all right, well, up to you what makes sense. In some scenarios, having fewer positions or fewer groups of players might make more sense if you want to get more like, if you want to find, I don't know, newer aggregations of players and stats or wherever. And in some scenarios, you want to be more granular with like the kinds of players. So I would say like when you are evaluating your clusters, it's very important to do that in context because the clusters I sort of like to think of clustering as almost like a suggestion of what your data could be grouped as, because you're sort of like creating these labels mathematically. So whatever your clustering results are, they are not always, what's the word? Like they're not ground truth. Like I guess ground truth in terms of math, but they're not ground truth because they're not taking too much context into account. In another scenario, I had a student doing clustering on NLP as well. And they're like, okay, well, it's telling me that the best is 4 or 5. Which should I pick? So then it went down to like, all right, what are you going to use these clusters for, right? I think that's also kind of similar to like that basketball problem, but especially when the clusters are so close together, like the difference between 4 or 5 might not be a lot. One important thing to also maybe take a look at is when you're doing 4 versus 5 clusters, is that one additional cluster, like, are they outliers or are they really just like another cluster split into half? Which brings me to my next point is something that could help a lot is visualizing your clusters. I should be pulling up a doc and writing this down, but you know what? I'll like try and summarize my thoughts later on and send them out to you all. If anyone is taking notes, let me know. All right, so visualizing your clusters. After you're doing clustering, you can do like a dot predict and get an array of all of your clusters for all of your data points. So for example, if you have 5 clusters, your dot predict will just give you the 5 clusters. With that, you can plot it on a scatter graph. But if you have a lot of features, usually what people do is you do something very, very similar to PCA. So PCA, as you remember, reduces your dimensionality to, a dimension 2 or 3 that you can plot. Reducing your dimensionality to something that's 3D or 2D will work as well, will allow you to see, all right, how are your points scattered around in space? So the one I wanted to tell you all about is a Teasney plot. So let me see if I can find one really quick 3D scatter plot. There we go. So let me quickly share my screen. There we go. So I've told you all that my favorite plotting library is Plotly. So this is Plotly, but you can also do the same with Matplotlib. What I like about Plotly, and of course, this is a very simple data set, but this is an example of a 3D scatter plot. Imagine these are your clustering results. What I like about Plotly is this is me zooming in and out by just scrolling up and down. Also, you can like rotate it around to just like see where your data points are, which I think is pretty cool. More specifically, so I said instead of PCA, there's another one that I did mention before, but not a big deal if no one uses it. It's not part of the curriculum, but it's called, oh yeah.
I'm kind of confused on how you use PCA with clustering, I guess.
Got it.
Aren't you going to be converting your like your features into their principal components, and then isn't it going to be like hard to interpret?
Yes, it's going to be hard to interpret, but then at least you can sort of see how your clusters are related to each other. Like for example, of course, this is very simplistic, but even though that this is, imagine that this was like 100 column data set that I PCA down to 3D. You will still be able to see some sort of like clumping happen with your different colors, with your different clusters.
Right, but so will those clusters be identifiable like as, for example, the species, or it'll be like PC, I don't know, some kind of range of PC components?
I see.
You know what I'm
saying? So got it. So when you're doing the PCA or any like dimensionality reduction, you don't include your like cluster result. You're only clustering like all of your X values, if that makes sense. Let me see if I can pull up it's going to take me a while to pull up an example, but you know what, I'll pull it up for next time. Okay. But the idea is, yes, none of these dimensions don't have any meaning after you reduce the dimensionality. It's more of to like inspect the distribution of your clusters. Like based on this, I know that the green cluster is closer to the red cluster.
Right. So there, I mean, I guess you can identify the clusters then, but if it doesn't have like any meaning, I don't know. I'm trying to think of it in like an NLP.
For sure. I guess. So one thing that you can do with here, after you do like the PCA or this other one I'm going to be telling you all about is Teasney. Really quickly, the difference between Teasney and PCA. PCA maximizes variance. Teasney helps with the separation of clusters. So usually if you're trying to display clustering results, Teasney is the preferred one. But anyways, back to this. With Plotly, I know that you can do your dimensionality reduction, plot the reduced dimensions, and then as labels, you can actually have it display the raw text of each data point.
Okay.
So you can use that as an identifier. Same for like, even if it's not NLP data, within Plotly, you can actually give it the labels. I guess this is, let me see if there's another example here. Is it symbol? Oh, this one basically changes symbols. But there is a way to tell it what to display when you hover over. This is, again, like a Plotly thing, not so much, well, you can't hover over Matplotlib or Seaborn. So, but yeah, that's one way that you can use to like identify your data points. And like in a quick way, quickly inspect like, all right, maybe like this guy and this guy are like close together. And then just based on whatever your results were. It's just, I think, a fun like EDA tool and an easier way to like look at the distribution of your clusters in a dimension that we can see. But yeah, in terms of like lowering the dimension, T-SNE works in the exact same way as PCA does. Your number of components. Again, I would say that T-SNE is used more for like just the purpose of, what's the word? The purpose of visualization. So you don't have to like tune it like PCA, you're tuning for the number of components. I would say 2 or 3D, such that you can have just some display of your clusters and what they look like. Also, if you have a lot of data points, just for anyone who's planning to plot something like this, if you have a lot of data points, you can imagine that like if you have 100,000 points here, it's just going to look like giant clumps. So feel free to just randomly sample like 100 from each cluster to just for the sake of plotting. So yeah. Any other thoughts or questions about this as I think of more things to say about clustering?
I think you may have already answered this, but you do not want to put your target variable into the clustering, right? You leave that.
That's right. That's right. I would say that there are exceptions depending on what it is that you're doing, but yeah, for the most part, you don't put your target variable in.
And then when you're trying to interpret your clusters, any suggestions, like if you're dealing with, a large number of variables like 30, how do you easily, or what are some strategies for like trying to see, okay, cluster 1, what is that really made up of?
Yeah, great question. I would say with clustering, in order to make sense of your clusters, I think that is something that is especially hard when it's not NLP data, because NLP is easy because we can comprehend the words that are in each document. So for something that isn't NLP, it is often necessary to do some sort of post-clustering EDA. So that means think about one, if you have an instinct of what features could be separating your clusters, start there. But also just doing like a quick, well, you have your data frame with all of your different clustering results. Doing a quick summary of the data points within each cluster to see, like, for example, let's say you divided your data set into 5 clusters, you add your labels to your data frame. Within cluster 1, if you just do a dot describe and look at like the average values for every point and do the same thing for all your clusters, you can sort of see where differences arise. That's a good place to start. Of course, like the averages won't tell you everything, but from there, you can start, that's like one way to start figuring out how your clusters differentiate between each other. So yeah, post-clustering EDA basically. Likely you will be able to run like the same set of functions on each. If you have like an okay number of columns, you can probably look at the distribution of your data points within each column, within each cluster. But yeah, that's only if you have like a decent amount of columns. I know a lot of you are working with very, very large data sets where that is not always possible. But yeah, maybe if you did dummy variables on something and you have like 10 unique values, maybe you can do like a bunch of like different stacked bar charts to see like, all right, maybe this cluster has mostly the first or second dummy variable, or like the second cluster has like dummy variable of like the 5th and 6th variable. Yeah, the 5th and 6th of the values of the dummy. So yeah, that's something that you could do. Again, depends on your data, but for the most part, you can usually start your search by looking at differences between the aggregated values within each cluster.
Thanks.
Awesome. Anything else? All right, I'm gonna look for an example of this. I know I have one somewhere, so I will maybe post a code snippet of it later on today. Let me just write that down.
I saw an article that had a cluster like heat map, and I was thinking of trying to do that. So just relative to the value in each of my dummy variables, I guess.
Yeah.
I don't know how to set it up. I haven't figured it out.
Can you send me that article? I'm curious as to like what the context of the heat map is. Like, are they doing a heat map per cluster or over like the entire data set, taking into account all of the clusters?
It's over the entire data set. So
okay.
I think he did 15 clusters, and then it's grocery data, and then he did like 15 aisles and just showed how many people, I guess, are in each. No, I haven't figured out what it is.
Okay.
How many orders or how many orders are in each
Interesting.
cluster. I did like a cluster metrics, and I calculated the max and min value for each column. And so that's how I could tell what my clusters are, is by seeing, oh, well, this cluster had, the highest number of orders, and this cluster ordered all the alcohol, and this cluster ordered all the kosher food. And it was really interesting, but I want to get it into a heat map, I think.
Oh yeah, I mean, feel free to send it over. It could be something that I can help like decode, and I'll post in like the channel or put in one of the documents somewhere. Because that sounds really interesting. I've never thought about like, or I haven't really figured out how it would heat map clusters. But yeah, I would love to see that. Very cool. Any other thoughts? I think all in all, like as an overview closing statement of clusters is that you have a lot of freedom in like adjusting clusters because, as I mentioned at the start, clusters are mathematically determined with very little context input. So if you're seeing that, all right, it told me that the best number of clusters was 7, but based on further inspection, it's obvious, at least to me with contextual knowledge about my data, that like clusters 5 and 6 can pretty much be the same thing. Feel free to do that, because mathematically it might not see that separation, but based on your inspection, sometimes based on like a chart like this, you could see that, all right, 2 of the clusters have fewer data points and are like closer together, so might as well combine into one. So you can definitely like hard code those aspects in. But yeah, clustering is something that you have a lot of freedom with. Feel free to, I don't know, it's definitely subjective and also, yeah, important to take into account the context of your problem. Don't feel like you're constrained by, the metrics or the scores, the number of clusters that you have. Cool.
Excuse me.
Oh, yes.
I have a question, but it's not about clustering.
All good. Can I do a quick call for any last clustering questions before we get into other things? Going once, going twice. All right, Ali.
I have really difficulties understanding the object-oriented programming. I know it's not a fair request, but would it be possible to live code, or you have an example of a class to, for example, explain it a little more? Because I don't know if the functions in the class should be in some specific orders, or where to use attributes, where to use objects.
Got it.
And how to use self.
Okay. Not right now, but what about next week? I can probably find something and talk through it next week. And because I think I remember, Ali, you're defining a bunch of functions within a class to use for like your whole project process, right?
Yes.
Okay, I can definitely put something together because I know you're doing that. If I find something that's a good resource, I'll send it to you. But if not, I'll go through it on Tuesday. But your functions do have to be in order if they're calling on each other. So if you have one function that's going to refer to another function, that other function has to be defined first. But yeah, other examples I can talk through on Tuesday with more time, because that is also one thing that I'm like, it's not always it's not always correct in my brain.
Yeah. Most of it are abstract, and it's a little bit hard for me. I don't know if anyone else has the same feeling or not.
Object-oriented programming is quite abstract, and it's something that takes a little bit to get used to. So yeah, I know object-oriented programming was like a requirement for our phase 1 project when I was a student. And so I am slightly traumatized, but also have like a weird amount of like knowledge in like a specific kind of object-oriented programming. So, and it's not, unfortunately, not the kind that you're working on. But yeah, we had to do object-oriented programming with setting up SQL databases, which was painful. But happy to do like a quick summary of that as well. But yeah, I'll put something together, or I'll find something that I can talk through, and we'll do that on Tuesday.
Thank you.
You're welcome. Anything else?
I have a question about how to make word clouds for NLP. I don't remember. I don't think it's in like the labs or anything. So I was wondering if there's like a method to do that.
Yeah, I think the library is literally called word cloud.
Word clouds, okay.
Yeah, so I think is it this one? Yeah, this is one of them. Let's see, is this the documentation? Hold on. Let's see this one. Hopefully they have some code. I know it's from word cloud, import word cloud. Yeah. So it's from word cloud, import word cloud. And then the default is like the black background with the different colored words. But I know that if you can also put like word clouds in different shapes.
Okay. So it would just be over any like set of text that you have, basically.
Yeah. So you actually feed it in. I want to say you feed it in like a frequency distribution, or you feed it in all of your text. Let me see. Oh yeah, generate text, and then text, I guess, is, yep. So I think text is just all the text.
Okay. Cool. So it's not difficult then.
Yeah, not at all. I have the code in my first NLP study group notes, but that's like the basic one.
Cool.
Awesome. Anything else at this point? All right. Some quick announcements before we break off with feelings. Next week, MVP presentations, I'm going to have like the order of presentations later by the end of today. So don't worry about not knowing when you're going to present. So I'll have that out by the end of today. I have gotten a few of you all requesting what day you do or do not want to be on. So happy to take those requests. So let me know. Also, there are going to be a couple NLP study groups. There's, I think, two hour-long sessions that are coming up. Thanks, Sarah, for setting those up. So I will post in the Slack channel about it, but one of them is going to be Wednesday at 5 p.m. and then another on next Monday, the 22nd at 2 p.m. So I'll post in the Slack channel about this. Anyone who's working on NLP, feel free to join in. Also, I know that there's like a NLP chat somewhere. So if y'all want to like put together questions or specific things that you want me to talk about, feel free to let me know as well. Cool. Yeah, that is all of my announcements. Does anyone have any like final thoughts, questions? Oh, I think one thing that would be helpful, a good place for you all to be by, I guess, end of today or early next week. Well, I think finally all of you have decided on your capstone projects, which is great. So as long as you are getting to work on EDA, I think that's a good place to be. As you all know, the modeling process, again, most of you all are doing like regressions or classification. So as you all know, the modeling process is pretty straightforward once you have all the code. Feel free to use your code from past projects. So that part will, I'm pretty sure will not take you more than a couple days. So if you're getting into your EDA by, I guess, end of today or Tuesday next week, you're still in a good place. And if anyone is like worried or wants me to help scope down their project, you can let me know too. All right, then. Let me stop this recording and then we can get into feelings as usual.